So what we'll be doing today here is trying to understand how we can do static analysis. This is a very nerdy topic, I can understand. So I wouldn't mind if you sleep through half of it, but it's okay. And we'll be trying to implement it for privacy. I mean, this has not been done before. It's a very big question. We'll try to do this. So I am Suchakra. I spend a lot of time analyzing computers and code, have been doing it for quite some time. I did my PhD in computer engineering from Polytechnic Montreal, and I write poems and click film photos. So if you like film photos, you should come to me. Yeah, you can know more about me here, so let's just begin. So privacy in modern times is actually living like this. Okay, you have your apps, and you have just two choices. Either you click, yes, I agree to whatever, and you sign away your soul, or you should just burn your money, and go to the Himalayas, and that's about it. Okay, so there's no middle ground in between. And I believe there is something that can be done. If we empower people who are actually building these things, we could actually come up with solutions where all the different personas that are supposed to provide privacy, they are all together and understand. So let's try to do that. This is a conundrum which I feel is there. So we are looking at what's happening to my data from the perspective of where it is stored, or trying to analyze it after the fact, actually. So, but I believe that data is produced by code. So it's kind of like a tap that is turned on and water is flowing everywhere. And on the other side are privacy operation folks, and they have a broom and they're trying to broom the water in. Okay, and it's really true. We can actually, I can give you a real example here. So this is a code from an open source app called Shopizer, and there is a small statement below which is like log.info, and there is username that is being logged. So it's okay. Developers don't mind having a few logs here and there. But what happens is that imagine 500 people are using this installation somewhere at a given piece of time, and they are going to generate a lot of data, and this data is going to go in multiple databases, and then one of them will be running a log scraping service, and then there's a human sitting behind in operations, never caring about what's there, and they see these logs in front of them. They're not supposed to see them, but they just see them. And so we can, the privacy folks will try to understand, okay, let me look at the DBs. Okay, now that's not working. Let's look at what services are running. Are there scraping services here? Is there any third party where they're putting this data in, like SendGrid and Sentry, things like that. So, but the problem actually can be solved by just one person who exactly knows where I'm producing this data. This data is being produced here. So there's an opportunity here, I believe, where we can empower the folks who are building this to actually solve this. So we want to build privacy tools which are relevant for developers and engineers. Okay, so but how do we do this? So there's this thing called static analysis. It's not ML, AI, or anything. It has been there for a long time. This is how much of your code that has been executing on mainframes and all these machines have been working for a long time. So we understand what this is, and we try to implement it for privacy. Okay, so what is static analysis? It's simply analyzing computer programs without executing them so that you can find the bugs when they will actually get executed. This magic, no? You can actually find out what's going to happen before it happens. So some important concepts that we need to know. There are many more, but these are the important ones, like sources, sinks, taints, and data flows. So sources, important places where data can start from, and then sinks are somewhere it can go, and taint is how it is being tracked throughout, and data flow is just everything, trying to find where this data went from here. And humans actually work like that. So if I give you the same piece of code, and there is a PII data to log, you can just instantly see it, and you see that there's some problem with it. There is a PII data which is being collected, and it is eventually going in a log. In your mind, in that 1 second, what you did is you created this big map. You were like, okay, this is an HTTP variable. Maybe in my app, this would be the handler, and okay, I need to start tracking it. So you make a note of it. You say, okay, this is my source, and then you start tracking it, and then you see, okay, this info looks suspicious. Then you try to understand where it is coming from. oh, this is of type logger, okay? It's coming from this log variable of type logger. This is Apache Log4j. I need to really track this. And using this in your brain, you can actually answer questions like this. Find a flow from a variable which is from PII geolocation source to a log sync function, which is of type package Apache Log4j. So you can literally answer these questions in plain English, but the code is complex, but you're able to do this. We want machines to do the same thing. That's kind of like the thing. So why should we do static analysis? So I believe code is the true container and producer of data. That's where the real action is happening. It gets produced, goes somewhere else when it's getting executed, but the producer is right there itself. And when it's not being executed, you can actually reason about it very calmly. When it gets executed and then you're trying to understand what's going on, it's like you're listening to death metal, going in a war, trying to understand, okay, what just happened here? But when it's not getting executed, it's like you can listen to classical music and look at paintings of Alps or whatever. So the goal is to find bugs early in the software development life cycle. Okay, did we introduce a PII variable? Right there, then in itself, you made a commit, and then it tells you, did you do that? So at runtime, detecting a leak means the game is already over. It's a very reactive approach. What we need is a proactive approach. So I'll run through interesting stuff very quickly. I've seen this kind of code. We'll do a deep dive. This is actually what happens. You have a single piece of code, int y, x plus 50, and then you have to do lexical analysis over it, tokenize it, and then the computer also converts it into a graph. Turns out that they also like graphs, just like humans made these graphs in the brain. And then you convert it to something called as abstract syntax tree, and then you enhance it, you attach more things to it, and then you get a control flow graph out of it. You can understand where the data is flowing from one point to another point, if statements, else statements, where it would go. And then all this eventually gives you a very nice thing, like a program dependence graph. So value of z dependent on the value of y, dependent on the value of x. But things are more complex. Real programs look like this. They don't look like one-line statements. So they have a lot of things. You have class, member variables, local variables, annotations, and all these new things that humans have. They have made their life miserable by introducing a lot of this stuff. And computers have to really understand this. So they can create these nice higher-level abstractions. A patient controller defines get patient method and it contains a call. So these all information is already there. What we have to do now is to bunch everything together. So we start building a code. We take the lowest layer and we create an abstract syntax tree there. Okay, and with that information, now we add some more information. We add control flow graph over it. So we know that, okay, this will now also have control flow information. And then the next is what humans will really understand, high-level relationships graph of what things are happening. But they get the whole context all the way below. They can ask deeper questions about operators here and there. So this brings us to this technology called as code property graph, which is a queryable graph which embeds complete code knowledge. There's a article there, you can read about it. It has been there for quite some time, 10 years, I believe. And this is essentially what this is. You have language front ends, code coming in, and then you can generate the graph, and then you can query the graph. So how do we use it? So there are many implementations of code property graph. 4 of them are important. I would say the first one is official. It has been there for 10 years, and then others have gradually been implemented. So we stick to the first one called as Yearn. It's actually named after a real person named Yearn. So you can go and check it out. But what it allows you to do this is it gives you a nice query language in Scala. And then you can ask questions the way we were supposed to ask it. So you have the code in front of you and you're going to ask it, give me all the logging sinks. Are they reachable by this PII variables called location? So you can see this is quite powerful. What if we could run thousands of these queries on millions of lines of code? We get insights about it, and we can get privacy insights about it. Is this kind of PII data gonna leak to this log, to this file, to this database? You can make permutations, and then interesting stuff happens. And that's what we did with this tool that we have built called as Privado Scan. We want to build this tool to scale static analysis for privacy. How does it work? So the 3 components of this thing, you can go on GitHub and check out all of this. There are rules, easy to define YAML rules. And then there's an engine which generates the graph that I just talked to you about, takes these rules, run these, converts it into queries, finds out data flows, interesting points inside the code relevant for privacy, and then a UX piece, which is just a simple CLI. And that generates your result in a JSON format. That's also open. You can check it out. You can also view it on a cloud UI, but if you only want to configure it, otherwise everything can run completely on your system. So there are some users who are actually using it. It turns out that they submitted a pull request, and we were like, hey, how are you using it? And then they said, yeah, we have a lot of stuff that we are building. They have customized their rules and everything. And it's essentially something like that. So they generate the CPG. They have their own YAML rules, which is there. You could also do that. And then you query this, and it gives you nice results. So if you want to check it out, it's just 2 lines of code below. Don't trust anything that an install.sh does on your system. You should go and look at the code. So, but I still gave you this link, obviously. So then the real command is like Privado Scan, and then you can scan it. So this presentation also has a demo. So you should start praying now that this works. Okay, so I have a piece of code, banking system backend somewhere. I don't know what it does. I mean, I know what it does, but you don't know yet. So we can actually do Privado Scan. And OK, you know, I don't want to write it. It's already there. So I have this banking system back in there, and I click Enter. Obviously, I had run this before. So it's using Docker. So we have Dockerized much of our static analysis pieces, which are there. And it detected the language Java. It's understanding that there are some configurations in it, property files, etc. And then it's downloading some dependencies and starting to parse code. So there may be some dependencies, so it's also fetching those. Yeah, a lot of the stuff that is going on here is, you know, you can configure it completely. Now this is static analysis, so you can sip a piece of, coffee. You know, not a piece of coffee, but like a sip of coffee. You know, it's so difficult, you know, languages. So we'll wait, really, like nothing else to do. That's why I said, you know, you can remain calm. You know, that's why it's static analysis. So a lot of stuff happened here. So as you can see, yeah, it went through the code. Let's come back here. So it went through the code, and then it ran. It started tagging interesting literals inside the code, interesting databases, APIs, trying to detect all of that. And it found out interesting flows, and then gave you like a simple, you know, thing here. So data elements 11, third party 1, and then some details about it, you know. And all of this information is in the privado.json, which you can actually go and look at it here. It also asks a question later on. I have set it to yes by default, where you can actually visualize these results. So we'll try to visualize those results. It's in our community dashboard. So again, this is shared. You don't have to use it, but I'm using it because I want to see these results. It gives you some information about 11 data elements, 0 sensitive, inventory, and then you know, all the data flows that it found, including the elements. So some of them don't actually have flows. So this is good. It found date of birth, but it's not going anywhere. But in some cases, it did find a lot of stuff. So this phone number is going to many places. So you have this phone number. It is being shared with something called as fast to SMS. And then it's getting stored to HDFC Bank, you know, some database. We don't know yet, but we actually found out by analyzing code. It is getting leaked to a console, getting processed, and also getting collected internally in your APIs, which is there. So this is all being done completely via static analysis. As an analyst, as an engineer, you can actually start to look at each of these things one by one. So we have this information embedded as well. So it looked at this phone number variable, and it started tracking it, kept on tracking it. Turns out it's going to SMS service, your customer ID, get value of, get phone number. So it's going out somewhere. So now it wants to find out what is this SMS service. So it goes inside SMS service, sees that, oh, it's going in the string, you know, and getting concatenated to the string, and then a URL connection, etc. is happening. Anyways, that's one example of data going somewhere outside. Same with databases, detects that there are some databases, multiple places where flow is going to, And it tracks this phone number also, and it gives you some information that this is a member of account. So now it will also track account. So if account is leaking somewhere, it will say that, yeah, phone number is leaking, because the account object now has phone number. So yeah, console and collections, it's the same stuff. You've seen it. You can explore it yourself a little bit. So it understands that this account is actually being collected via this add account handler. And so it says that this is a phone number because the account object has the phone number inside it. Great. So that's the end of the demo. There are other things also, inventory to do the reverse stuff, which means like you can try to understand what is going inside fast to SMS. So you can see that, okay, phone number, account, password, all these things are getting shared. So you can do the reverse thing also. There are issues also. You should explore it. There is work to be done in actually writing this properly in YAML. I would suggest do that. Patches are absolutely welcome here. End of demo. This brings us to some links that I wanted to share with you. Let's see. Docs are here, rules and engine. So all the different repos are here. You can join the Privado community with this link, and I will send this on Slack. And if you want to do more deeper stuff, then there is Yawn community that you can join, and contributions are absolutely welcome.